It's so tight in here. Made like. So tight.
Oh, one's in a wheelchair and one's pushing it.
But we don't need to start with that.
No. Go ahead.
Yeah, it's gonna be a while.
It'll be like 10 more minutes.
Maybe 20.
30.
Go slow.
An hour.
Just go ahead.
All right. All right. I'm easy, huh? All right. So let's do this. I'm gonna turn the lights off, and it's probably gonna affect the video.
I'll be fine.
I'm gonna put everybody to sleep. Yeah. So the activity today is movie making at your fingertips. We're not going to make movies like you see in Hollywood, if you will, but you'll make your own little movies. And but before we do that, we want to give you a little bit of background in terms of what computer science is and computer science at Virginia Tech. My name is Professor Feng, and I'm here with a number of my own colleagues and students. So in the back, maybe actually why don't people come up here so that they can see you briefly. And we'll assign each one to one of the rows so that you have a resource to ask questions of. Yeah, that's fine. Start here, Jacqueline here. We'll start with Jacqueline. Go ahead. Well, just introduce you. Just say your name. Oh, let me. All right, I'll forget it. I will do this before. This is Jacqueline Odessa. She's actually I guess, alumni of the CTEC 2 program to some degree. So you can ask her more questions. And I'm going to let each of the guys down here introduce yourself. Just name, rank, serial number. just give your names, and they'll be assigned each one to one of these rows. So hopefully, not that you will remember, but we'll go ahead and go through.
Okay, sure. Hi, Tom Skoglund. Just finished my second year of graduate school here, working on a PhD in computer science.
I'm David. I'm going to be a junior next semester in computer science.
I'm Andrew. I'm going to be a junior in computer science next semester.
I'm Mark Gardner. I work for the Office of IT and do a lot of collaboration with Professor Feng.
I'm Scott. I'll be a junior in computer science and computer engineering.
I'm Drew. I'll be a junior in computer science and math.
I'm Scott also, and I'll be a rising junior. I'm a rising junior in computer science and
My name is Adam, and I'll be a senior in CS.
We'll come back full circle on the third.
I'm Jacqueline. I'm going to be a junior in computer science and math.
Okay. These are the people that will be helping us today. Get them back and. So I'm going to talk a little bit today, I hope no more than 10-15 minutes about computer science, and then we'll get going with the actual activity. I know that we're on a hard deadline of 6 o'clock, I was told. So up at the top are some other professors from the department.
Sorry, I put them in the wrong place.
That's okay.
My fault.
This is Professor Manuel Perez Quinones. This is Professor Eunice Santos, and then on the top is Professor Demetrios Nikolopoulos. So the first thing we want to ask is, what is computer science? So, what do you think of when you think of computer science?
Programming.
Programming. Excellent. That's exactly what I wanted to hear. Because, and I swear I didn't give anybody the slides. So this is exactly what it is. This is about programming. And if it is about programming, are these the kind of images that come to mind? And I would expect that this is what people largely think of, right? Okay. Well, first off, I would say that it's not just about programming. If it were, we'd rename it computer programming rather than computer science. However, I will say that programming is integral to what we do in terms of computer science. The programming is a means to an end. The programming will help support something that is of vital interest to you or your friends or society. And you can already think about things like web browsers and things of that nature that you've just learned to grow up with, and we're going to talk a little bit more about that. So you take a look at computer science in the College of Engineering, you start to scratch your head and you think, well, computer science, wouldn't that be in the College of Science? Why is it in the College of Engineering? And so if we take a look at what computer science is, or let me rephrase that. What science is that when you look at the definition for science, I think I pulled this from Wikipedia or something like that, it's obtaining knowledge of the physical or material world through observation and experimentation. So it's an introspective look at things. You want to figure out how things work. You want to figure out why bees, oh wait, I don't know if bees do that, why birds fly south in the winter. You want to figure out why a flower blooms when it gets water and versus when it doesn't get water and what have you. So it's about the study of how things work. You're looking inward generally. And computer science is that way because you sometimes want to figure out how computers work, like how the laptops in front of you work or how desktops work. It's also, you can look at, in terms of the engineering part, so I just said the science part, engineering is making practical application of the knowledge of the pure sciences, from the physics and the chemistry, in order to construct new artifacts. So like building bridges, building ships, and building computers. And so it's about the design of how to build things. And so it's more of an extroverted thing. So one, you're looking more inward, the other one you're looking more outward. And the question is, well, what is computer science? And in fact, computer science is both. It's a science and an engineering. And in many universities, you'll see it as computer science and engineering. And this is also the reason why computer science is in the College of Engineering here. It's both a science and engineering. We study computers to try and understand how they work, how to make them better. We also have engineering because we build things. And I'll give you some examples of that. Come on. So let's take a look at the importance of computer science. So let's take a look at how many computers your family owns. So how many people families own one?
Is this one or more?
One or more. All right, thank you. 2 or more, 3 or more, 5 or more, 8 or more. Oh, that's scary. 10 or more.
I think we have like 11 or 12.
11. 15 or more. Okay, we stop. All right. All right, so I think it's actually more than you might think. You own 40 or more. And so why would I say you own 40 or more? Well, what is a computer? Well, if you look at what the inside of a computer is a processor, and it has some memory, and it has some storage, and it has typically some type of visual input-output interface.
Our cell phones are computers.
Exactly. This is a computer. It has an ARM-based microprocessor in it. It has, as I recall, it has an ARM-based microprocessor. It has some memory, and it has storage. This particular version, I think, had 20 gig. This is one of the first ones that was out there. This is a computer. It just doesn't look like your traditional computer because you're thinking about keyboard and display and mouse and things like that. But this is a computer. It just has a different type of interface. You operate it through this input interface and this input-output interface of the display. The iPhone. A digital watch. This is a Roomba vacuum. It's a computer. Digital thermostats right now are computerized. Speaking further about the home, you have digital frames. This is a digital frame that has it'll have a processor in it. It has memory. It has storage in it. Not all of them do. You could probably use a USB key for storage. Staying in the context of the home, this one's a little bit of a stretch, the LCD display, but what I really wanted to get to is that we take those LCD displays, you can take a look at GPS systems in the car, and where do the rest of the microprocessors come from? It's in a car. typical car will have anywhere from 30 to 50 computer systems inside of it now. Back in the early 80s, there were 0. And around mid-80s, the Ford Escort and some other cars, they started to have 1 computer in it. And now it's gotten so much to be on the order of 50, and if you did a quick look and did a Google search on how car computers work, you'll see that in this particular case, you'll see down here, cars today might have as many as 50 microprocessors in them. So there are 50 computers that are operating your family's car. So computer science is pretty important. It's even keeping Ford competitive. This, in fact, just came out a few days ago, July 2nd. Ford bets redesigned Taurus will be key to the financial future. They use computer design to bypass the costly and time-consuming building of multiple generations of prototypes. And this is how they're looking at trying to stay competitive in the global economy. If we take another perspective of what computer science is, it enables us to create virtual worlds for work. And you have people that will work in things like flight simulators to figure out how to fly a plane. I don't know how many of you had driver's ed and you actually use a driver simulator. Anybody? A few people. Okay, good. I learned how to drive in the driver simulator. You get into a system and it would simulate driving conditions for you. And that's the way you learn to drive before you move to a real car. And this is an example here at Virginia Tech. There's a gal in here. She has some 3D goggles on here, and she's in what we call a cave, an immersive cave, and you can't tell that she's flying, but in her own view in her goggles, she's flying through a DNA helix. So these are all the things that computer science will enable in terms of virtual worlds at work. Here's another one, and I don't know if people are going to be able to hear this. Let's see. So this is a trauma room simulation, all using computer science to be able to
This is a demo of the trauma room simulation that we developed for Korean hospitals. It was designed to train resident doctors on trauma situations and evaluate their performance during the same. The simulation starts with an option screen that allows senior doctors to choose the kind of trauma room scenario they want to train their residents in. The scenario begins with a description of the patient's health condition by the emergency medical technician. The user interface is designed to be simple and only requires the use of
the audio is kind of hard to hear, but you can see the types of things that people do. There's even places now in hospitals what they'll try to do is be able to teach surgeons remotely at different sites because they have expertise in one site and they're trying to train surgeons at another site. It also enables us to do things for virtual worlds for play. These are things that you may be familiar with: the Wii, the Wii game console, the PlayStation 3. This is a Sim City, which allows you to build your own city and create your own governance and try to build your own utopia. These are car racing games. There's karaoke and DDR, Dance Dance Revolution. I don't know how many people know what that is. So these are all computers. You can look at it as enabling us to enhance and enrich life. Take it for granted now, but cash registers are no longer around. They're called point of service, I think, machines. And they're computerized, essentially computerized cash registers. Air traffic control, CGI, computer graphics for movies. And of course, we've taken it for granted that we don't necessarily go to a store or a bookstore to buy paper maps. We just take it for granted. We just go to Google Maps. If we need to travel, to book travel, we'll go to some place like Expedia or Travelocity or what have you. You don't necessarily go to travel agent anymore. We use it to build communities. I suspect there's a Facebook for CTech too, right? So, and many of you probably use Twitter as well. There are other communities out there. There's Blackboard. Blackboard, if you come to Virginia Tech, actually not just Virginia Tech, many universities out there, You'll see some version of Blackboard, and that's a way to communicate information to students through an electronic medium. There's other communities like Green Grid, which is trying to make computing technology more energy efficient or more green. These are just a few examples. There are many, many out there that I'm sure I'm not covering. There's even the community that Barack Obama used and leveraged to get elected president. You also want to be more competitive in business. We already showed you this example from Ford. The stock market, hedge funds, D.E. Shaw and Company is a multi-million-dollar hedge fund company. It's located in Wall Street. This was started by a computer scientist at Columbia University. He figured out a way to automate things with a computer to make boatloads of money. And believe it or not, Procter & Gamble. Where do you see Procter & Gamble? Beauty parlors. Where else would you might see it? There's a place that you see it everywhere. You can't get away from it. Anybody in the back row know? Any of the students?
Grocery store.
Grocery store, exactly. So you go to a grocery store, just about everything you see, diapers, towels, tissue, they all come from Procter & Gamble. Procter & Gamble also makes Pringles. And here they're using computational fluid dynamics in order to figure out how to shoot the Pringles in such a way so that they get stacked up nicely into the can, because they fly off of the manufacturing assembly line, and they fly off, and they've got to press all the potatoes into the can without crushing them. So they use computers to do that. And of course, our own Virginia Tech Corporate Research Center, there's 140 companies, 2,000 employees, just here in little old Blacksburg. You want to solve important problems. This is a picture of Hurricane Katrina and the predicted paths that the computer models did for it. This is a picture of ocean climate modeling. See how the waters around the world are changing in temperature. So you can see along the equator the water is quite warm, and then out by the north and south poles they're very, very cool. We also have something that's more closer to heart here, closer to home, is that swine flu. And there are many ways to go about trying to attack biological problems through computing. There was one before this that we were involved with called the SARS virus. I don't know how many of you remember that. But it would take 5 days for them to sequence the virus. And with new software such as this, it would take 2 days. Integrate, communicate, and preserve information. We're all hopefully aware of instant messaging, the web browser, Google search, and so on. And then there are information aggregators like Yahoo's site, and there's a number of ratings types of sites like Dig that helps rate news sites. StumbleUpon over here is used for a recommendation site. So if you're looking for recommendations of what things to buy and do, you can go there. Delicios and LinkedIn. And computer science will hopefully allow us to invent the future. I don't think I'll see a flying car in my lifetime, but you can imagine here, this is like an iPhone that's projecting something down here and allowing you to do some input and output to it. And this is a picture of the Minority Report with Tom Cruise, a futuristic kind of display. And unfortunately, because the audio is not as good as I expect, I was going to do this a little bit. How was it? Could you people hear the last audio?
I can hear it.
Suppose you had a problem that was 100 yards long, and the faster you could go from the start quicker the finish, the faster you can divert the outbreak of a deadly plague, or find ways to combat global warming, or build a lighter, faster plane. Or imagine, when you cross the finish line, you would understand a complex biological process so well, you would be able to cure disease, or even extend life itself. Well, right now, corporations, universities, and governments from around the world are lining up for the race of the century. It's a race to solve.
In the interest of time, I'll move on and just finish up with computer science at Virginia Tech. So this is an example of Jamaica Berg. She had an IBM fellowship. You see that it's much more about than just computer science. She's pursuing a PhD in computer science. She actually finished it. She's graduated now. But her research is also spiced with anthropology, sociology, psychology, and psycholinguistics. And this was kind of tongue-in-cheek, it looks like, as well as observing cranky couples trade barbs in computer instant messages. And that was part of her human-computer interaction research. We have supercomputing and energy-efficient computing, where you aggregate a bunch of computers to be able to solve problems faster than you would be otherwise able to. So just like what that video was talking about, the faster you'd be able to solve a problem, the sooner you'd be able to control or address an outbreak of disease or virus or what have you. There's a lot of work in computational biology here. That's one of the areas that Virginia Tech's well known for, as well as, oops, I went back to you guys, as well as visualization. Anybody know what this is an overview site of, a picture of, that we're looking down on? This guy's got like 20-some displays around him. Anybody recognize that?
The campus?
It is a campus, arguably, but it's not Virginia Tech campus. The giveaway would probably be this right here.
The DC?
Yeah, it's DC. This is the mall, and there's the. So this is high-resolution visualization. Obviously, if you just had one display, this is like a 20-some inch display. If you had one display, you'd only be able to see this. But of course, now you've got this panoramic view, given that you've got all those displays up. Something that people oftentimes ask about, and I just updated this slide, is the 20 high-paying, actually meant highest-paying, the 20 highest-paying jobs for 2009. All top 20 involve computing. I didn't have room to put them all up here. And there were 4 in particular that focused specifically on computing. And you can see the mean salaries for each of these, as well as the projected employment numbers. And this is from the U.S. Bureau of Labor and Statistics. I'll try to make this available on a website, which I hope to get to just at the very end of this in another minute or two. And interestingly, despite the rosy job outlook, there's been a downturn in interest in computer science and engineering, although over the last year it's been turning back up. And this is particularly important given how strong the job market is in the computing field. So if you look in science and engineering over here, this is again from the U.S. Bureau of Labor Statistics, 71% of the science and engineering jobs are going to be devoted to computing people. So this is that was a brief overview of computer science at Virginia Tech. And we have a lot of members. These are all members that actively recruit at Virginia Tech. These are our premier members. We have a very large cadre of companies that look towards recruiting here. And you'll see that it's not the traditional companies that you think about when you think about computers. This is a utilities company, Duke Energy. They very much look for computing people. These are defense companies. This is a storage company. This is a financial consulting company, and so on. With that as a close, I guess what I want to do is, yes, question.
There's different, well, we had this sort of overview thing about all the different types of engineering at the beginning, and they said human-computer interaction, which is what I'm interested in. And if I majored in computer science, would I be able to focus on human-computer interaction, or?
So, yeah, that's a good question. So what would happen is in your first 2 to 3 years, you wouldn't get to focus on human-computer interaction right away.
Okay.
Because there are a lot of fundamental ideas and concepts that you have to learn that permeate across all the disciplines, from human-computer interaction to high-performance computing to all these, all these myriad of related areas. So you would take that foundational body of work first, and then by the time you get to your senior year, then you can focus on a particular track.
Okay.
So you can then focus on human-computer interaction, or another person may focus on computational biology, and another person will focus on, because by the time that you're done with your junior year, you then have the base foundation knowledge that you need to build upon for your particular expertise, area of expertise or interest, I should say.
Okay.
Yes?
I have 2 questions.
Yep.
One is, which programming languages do you use most?
So right now in our curriculum, it's an evolving thing. We're primarily working with Java and C, and there's a little bit of C++ in the comparative languages class that we have here. So it centers around those languages: Java, C, C++. Those are the languages that these companies tend to want to find. But you want to think a little broader than that. The idea is in computer science, we want to equip you with the capabilities to be able to do any language that you want to. If we can teach you the concepts, the abstract concepts appropriately, you'll be able to just pick up the languages quickly at least that's the idea.
Okay.
You had another question.
And how much experience with computer science do most incoming freshmen have?
Oh, that's an excellent question. So the question was how much experience with computer science do incoming freshmen have? And I think it varies. It widely varies. There are some people that don't have any, to people that have taken AP Computer Science and have tested out of classes. Jacqueline, what about your case? I mean, you could.
When I came in, I had taken dual enrollment for the first 2 semesters of the computer science, and I'd done an internship doing computer science for 2 years at a nuclear power company. So I came in with a lot comparatively, I guess, but you don't really need that much. I mean, it starts at the beginning. So I ended up having to retake some of the stuff that I'd already done.
Other questions? Okay, so there's one, if you all open your browser just real quick before we start our activity, what I want to let you know is if you go to research.cs.vt.edu, /CTech2. Oops. You can find out, I hope to have the presentation that you saw in PDF format posted soon there. You'll find other information there, including we're going to give you installation instructions for how to install the software that you're going to be playing with over the next half an hour. And so that's where you'll be able to go for that resource. If anybody's having troubles getting to it, raise your hand and somebody will come around to help you. In the meantime, after you've gotten that up and just taken a quick look at it, you'll see the, I forget what all's on there. There's a presentation, there's a link for installing and setting up Storytelling Alice, which is what we're going to use to make the movies today. Because we've already pre-installed it here, but if you wanted instructions on how to install it at home, you can just go there and get those instructions. And then there's a guide to getting started with it, which you may or may not use during this activity. So if you would close that, or at least get to the desktop again, and look for this particular shortcut, Alice shortcut, or look for the girl with the, I want to say bandana, it's not a bandana. Headband, thank you. And double click on it. It's going to take a little while to start up. And if you get what I get, you just hit yes. It's trying to change your display settings to an 800 by 600 pixel display. And if you have any problems, there are people over there. In fact, maybe each one of you want to take a row and make sure that everything's hunky-dory.